Hi viewers, here we will see how to resolve a force along some direction and perpendicular to that direction. So let's say this is a force F and this force has an angle theta with the horizontal. So the two components of this force along the horizontal and perpendicular to that means to the vertical will be as this, that the component along the angle will always be with cosine theta. So it means F force will always have the angle, always have the component here, and this component will be the force times cosine of the angle. So force F have the component along the angle F cosine theta, and the component which is opposite to the angle, like the angle is on this side, so this component is opposite to that, so this component will be F sine theta, because we know that cosine theta is opposite over hypotenuse and cosine theta is adjacent over hypotenuse and sine theta is opposite over hypotenuse. So the component along the angle will be with cosine and which is opposite to the angle will be with sine. Now see another example, that if the angle is not here and the angle is here, so same force F, now we are resolving horizontally and vertically. So in this case the component which is here, and since it is along the angle, so now this will be F cosine theta, and the component which is opposite to the angle here, that will be F sine theta. And now if the force is acting towards the object, here is the object, in this case here was the object and here was the object. So the first two examples were when the force F is a pulling force. Now force F is a pushing force, so having an angle theta here, so simply this component will be also a pushing component, so the arrow will be on this side. So pushing force will have the components also pushing forces. So this will be F cosine theta as it is along the angle, and this will be F sine theta which is opposite to the angle. And same situation if we have the angle here and this is the force F, so the component along the angle here will be a pushing force, so it will be like this downwards, so this will be F cos theta because it is along the angle, and the component here will be acting towards the object, means a pushing force, so this will be F sine of the angle theta. So same case, if this is the force F, just as a different case. So let's say if this is the angle theta, so the component along the angle will be here. It's a pulling force from this point. So the component is also pulling force. So it is F cosine theta, and the component here which is opposite to the angle, because the angle is here, so it is opposite to the angle. So this will be F sine theta. And now see this case here, if we have the angle here, so then simply it's a pulling force, so the component will also be a pulling component. So this is F cosine of the angle because the angle is here, so it is along the angle, and opposite to the angle will be here a pulling force, so this will be F sine theta. That's it.